we're going to start by talking about the limit of a function and some of the limit laws. But the first thing we want to do is just consider the graph of the function f. So just kind of like we did in pre-cal. First of all, think back. I want you to tell me what's the domain or what's the restriction in the domain. What about this denominator down here? What value can x not be? So basically, the domain is defined everywhere except for at 1. Okay, so we remember some of that, and then we also plugged in some points, some x values and y values. If you plug in the x value of -2 into our original function, so let's put that in, let's just do 1. -2 cubed minus 1 over -2 minus 1. We'll simplify that here, and this is just going to give us -2 cubed, which is -8 minus 1, so what do we have? -9 divided by -3, which simplifies to 3. Okay, and so we could do the same thing. And if I was to plug -1 in here and simplify this, we would just get 1. If I plugged in a 0, 0 is real easy, right? I would get 0 minus 1 is 1 over -1, so -1 divided by -1 is 1. Okay, just to save some time, because that's just a basic review of what we've done in pre-cal, we'll fill out this table. So I would have 2, 3, 3, 1, 1. What happens when it was at 1? What did we say? Undefined, right? Because if you have 1 minus 1, 0 in denominator, we've had undefined. 2, 7. Then even if I did -1/2, I would get 3/4, and -3, I would get 7. So roughly over here, if we tried to plug those in, let me pause it so I can sketch it. Okay, so we have an image like this, and we talked about some notation earlier in pre-calculus when we say the limit of f of x as x approaches a particular value, and we're going to talk about that in just a minute, but keep in mind this image. When I shift up, it's going to kind of fade, but when x is 0.5, the f of x value is 1.5. So this is still just a different notation. If we take this table, we got this graph. Now for this one, I'm going to plug in 0.5 for x, and I'm going to give you the values. Okay, so we're going to look at these. So this would be 2.71, 2.97, and you can put these in algebraically and test these if you like. But what we're going to look at in just a minute is the idea, this concept of a limit. Okay, so once we have these in, the limit of a function is the value the function approaches at a given value of x. Okay, so we say the limit of f of x as x approaches 1 is, let me put this back. Okay, so if I get on this thing and as I'm approaching x, the x value of 1, where is our function going? What's the y value? 3, right? So what we would have here is the notation is 3. So we would say the limit of the function f of x as x approaches 1. Okay, and also we remember when we did left-hand limits and right-hand limits, when we did x approaches 1 from the right or x approaches 1 from the left, we would say is equal to 3. Okay, or to be more specific in this particular answer, we could say the limit as x approaches 1 of f of x. What was our f of x? X cubed, the original function that was given, x minus 1. We can be even more specific instead of saying just f of x. And we can list this. So now let's talk about this. Remember we said as x approaches 1 from the left or the right. Let me get this back. Okay, if I'm approaching it from the left, that means I follow my function and I'm heading toward the x value of 1. Here's the x value of 1 right here. So where am I approaching? 3, the y value of 3. What if I did as x approaches 1 from the right hand side? Where does it approach? 3. So if the limit from the left and the limit from the right match, then the limit of function of f of x approaches just 3. It exists. Okay, let me clear this stuff. So basically it's saying the existence or non-existence of a function f of x at a particular point, x equals c, has no bearing on the existence of the limit as f of x approaches, as x approaches c. So just because the limit doesn't exist at this, the value f of x doesn't exist there, it's an open circle, we can still have that the limit exists. Okay, because it's undefined at x equals 1. But what's the limit of the function as x is approaching 1? So let's approach 1. As I'm going towards 1, what's the value? 2. As x approaches 1, if I came from the other direction. 2. So we would say the limit exists, but the function's not defined at that point. Make sense? So what you want to keep in mind is basically that the limit of the function is the value the function's approaching at a given value of x, regardless of whether the function actually reaches the value. Okay, so this is just our informal definition. It's the same thing to just say what we tried to show in function notation. It just says if f of x, the function becomes close to a unique number L as x approaches c from either side, we say that the limit of f of x as x approaches c is equal to L. That's just the formal notation for any function, any value of x. It just lets it be defined by that. That implies two statements. The limit exists and the limit is L. Okay. Some functions do not have a limit, but those that do cannot have two different limits. Like you can't have the limit from the left be 3 and the limit from the left be 5. That limit does not exist. And we'll talk about some of those examples in just a minute. We have a whole page of particular ones that don't exist. So let's just look at these couple examples. Find the limit of the following. So the limit of this particular function as x approaches -1. So as we're approaching the x value -1, let me get here. As I'm going towards -1, from the left or from the right, what y value are we approaching? Looks like 3. Yeah. Yeah. Okay. So what about b? The limit of 2x squared of this particular function that's graphed for us as x approaches +2. So as I'm approaching it from the left and I'm getting to the x value of 2, okay, or I'm coming from the right and I'm approaching the value of 2, where do we find ourselves? Y value of 8, and it really helps that the ordered pair is labeled right there, because if not, it can be a little bit difficult to see. Okay, let's see, 2 more. The limit, this time they didn't give us the actual function, they just said f of x, but they gave us the graph of it. So different notation, different things. Limit of f of x given by the picture as x approaches 3. X, if I'm looking at it coming from the right, left, as I'm approaching the x value of 3, and I look at it coming from the right, where's the function? 0, the y value of 0. Good. All right. What is f of 3 though? The function evaluated at 3. 2. Yeah, so that's the difference. So we want to know that there's a distinct difference between the limit of a function as x approaches 3, where's that function approaching, versus what is the value of f of 3. Okay, good. All right, let's look at D. Limit of f of x as x approaches -2. So here's -2. So as I'm going to -2, I'm down here, arrow pointing down, headed towards -infinity. But if I'm approaching it from the other direction, +infinity. So how can I possibly say what the limit's approaching? What's your conclusion? Does not exist. Okay? Does not exist. And just like I promised you, look at some particular cases which limits do not exist. The three cases is if the function approaches a different number from the right as it approaches from the left. So when I look at the left, I go to a y value of 3, and I come from the right and I get a y value of 2, that limit does not exist. Particular example here, from the left we're at -1, from the right we're at +1, so we would just say does not exist. The limit of the function as x approaches 0 does not exist. That is the first case. The second case is if it increases or decreases without bound as x approaches c. Okay, so f of x as x approaches 0. So as I'm heading towards 0 from the left, I'm going without bound. If I'm heading towards 0 from the right, I'm going without bound. This does not exist. Okay, because it's going on to infinity. There's no particular place in which we stop to say, here's that value. And similarly, if it oscillates between two fixed numbers, so number 2 was the example for 2, and oscillates between two fixed values, it's a particular case in number 3. So as x approaches 0, it does not exist because it jumps back and forth in very small increments. So those are the cases in which limits do not exist.